Hello guys, welcome to this channel. Today's we going to show you about atmosphere of the Earth. What is atmosphere? Atmosphere, mixture of gases surrounding any celestial object that has a gravitational field strong enough to prevent the gases from escaping, especially the gaseous envelope of Earth. The principal constituents of the atmosphere of Earth are nitrogen, 78%, and oxygen, 21%. The atmospheric gases in the remaining 1% are argon, 0.9%, carbon dioxide, 0.03%, varying amounts of water vapor, and trace amounts of hydrogen, ozone, methane, carbon monoxide, helium, neon, krypton, and xenon. The mixture of gases in the air today has had 4.5 billion years in which to evolve. The earliest atmosphere must have consisted of volcanic emanations alone. Gases that erupt from volcanoes today, however, are mostly a mixture of water vapor, carbon dioxide, sulfur dioxide, and nitrogen, with almost no oxygen. If this is the same mixture that existed in the early atmosphere, then various processes would have had to operate to produce the mixture we have today. One of these processes was condensation. As it cooled, much of the volcanic water vapor condensed to fill the earliest oceans. Chemical reactions would also have occurred. Some carbon dioxide would have reacted with the rocks of Earth's crust to form carbonate minerals, and some would have become dissolved in the new oceans. Later, as primitive life capable of photosynthesis evolved in the oceans, new marine organisms began producing oxygen. Almost all the free oxygen in the air today is believed to have formed by photosynthetic combination of carbon dioxide with water. About 570 million years ago, the oxygen content of the atmosphere and oceans became high enough to permit marine life capable of respiration. Later, some 400 million years ago, the atmosphere contained enough oxygen for the evolution of air-breathing land animals. The water vapor content of the air varies considerably, depending on the temperature and relative humidity. With 100% relative humidity, the water vapor content of air varies from 190 parts per million, ppm, at -40 degrees Celsius, -40 degrees Fahrenheit, to 42,000 parts per million at 30 degrees Celsius, 86 degrees Fahrenheit. Minute quantities of other gases, such as ammonia, hydrogen sulfide, and oxides of sulfur and nitrogen, are temporary constituents of the atmosphere in the vicinity of volcanoes and are washed out of the air by rain or snow. Oxides and other pollutants added to the atmosphere by industrial plants and motor vehicles have become a major concern, however, because of their damaging effects in the form of acid rain. In addition, the strong possibility exists that the steady increase in atmospheric carbon dioxide, mainly as the result of the burning of fossil fuels since the mid-1800s, may affect Earth's climate. See greenhouse effect. Similar concerns are posed by the sharp increase in atmospheric methane. Methane levels have risen 11% since 1978. About 80% of the gas is produced by decomposition in rice paddies, swamps, and the intestines of grazing animals, and by tropical termites. Human activities that tend to accelerate these processes include raising more livestock and growing more rice. Besides adding to the greenhouse effect, methane reduces the volume of atmospheric hydroxyl ions, thereby curtailing the atmosphere's ability to cleanse itself of pollutants. See also air pollution, climate, smog. The study of air samples shows that up to at least 88 kilometers, 55 miles, above sea level the composition of the atmosphere is substantially the same as at ground level. The continuous stirring produced by atmospheric currents counteracts the tendency of the heavier gases to settle below the lighter ones. In the lower atmosphere, ozone, a form of oxygen with 3 atoms in each molecule, is normally present in extremely low concentrations. The layer of atmosphere from 19 to 48 kilometers, 12 to 30 miles, up contains more ozone, produced by the action of ultraviolet radiation from the sun. Even in this layer, however, the percentage of ozone is only 0.001 by volume. Atmospheric disturbances and downdrafts carry varying amounts of this ozone to the surface of Earth. Human activity adds to ozone in the lower atmosphere, where it becomes a pollutant that can cause extensive crop damage. The ozone layer became a subject of concern in the early 1970s, when it was found that chemicals known as chlorofluorocarbons, CFCs, or chlorofluoromethanes, were rising into the atmosphere in large quantities because of their use as refrigerants and as propellants in aerosol dispensers. The concern centered on the possibility that these compounds, through the action of sunlight, could chemically attack and destroy stratospheric ozone, which protects Earth's surface from excessive ultraviolet radiation. As a result, industries in the United States, Europe, and Japan replaced chlorofluorocarbons in all but essential uses. The atmosphere may be divided into several layers. Layers of the atmosphere. 1. The troposphere. In the lowest one, the troposphere, The temperature as a rule decreases upward at the rate of 5.5 degrees Celsius per 1,000 meters, 3 degrees Fahrenheit per 3,000 feet. This is the layer in which most clouds occur. The troposphere extends up to about 16 kilometers, about 10 miles, in tropical regions, to a temperature of about -79 degrees Celsius, or about -110 degrees Fahrenheit, and to about 9.7 kilometers, about 6 miles, in temperate latitudes, to a temperature of about -51 degrees Celsius, or about -60 degrees Fahrenheit. 2. The stratosphere. Above the troposphere is the stratosphere. In the lower stratosphere the temperature is practically constant or increases slightly with altitude, especially over tropical regions. Within the ozone layer the temperature rises more rapidly, and the temperature at the upper boundary of the stratosphere, almost 50 kilometers, about 30 miles, above sea level, is about the same as the temperature at the surface of Earth. 3. The mesosphere. The mesosphere is the next layer of the atmosphere. It extends from the top of the stratosphere to about 85 kilometers, 53 miles, high. The temperature in the mesosphere decreases with increasing altitude. This is because there is very little air in the mesosphere. The air in the mesosphere is so thin that it does not absorb much energy from the sun. The is characterized by a marked decrease in temperature as the altitude increases. 4. The thermosphere. The thermosphere is the outermost layer of the atmosphere. It extends from the top of the mesosphere to about 600 kilometers, 373 miles, high. The temperature in the thermosphere increases with increasing altitude. This is because the air in the thermosphere is very thin. The air in the thermosphere is so thin that it does not absorb much energy from the sun. However, the air in the thermosphere is heated by the sun's ultraviolet radiation. From investigations of the propagation and reflection of radio waves, it is known that beginning at an altitude of 60 kilometers, 40 miles, ultraviolet radiation, X-rays, and showers of electrons from the sun ionize several layers of the atmosphere, causing them to conduct electricity. These layers reflect radio waves of certain frequencies back to Earth. Because of the relatively high concentration of ions in the air above 60 kilometers, 40 miles, this layer, extending to an altitude of about 1,000 kilometers, 600 miles, is called the ionosphere. At an altitude of about 90 kilometers, 55 miles, temperatures begin to rise. The layer that begins at this altitude is called the thermosphere. Because of the high temperatures reached in this layer, about 1,200 degrees Celsius, or about 2,200 degrees Fahrenheit. The region beyond the thermosphere is called the exosphere, which extends to about 9,600 kilometers, about 6,000 miles, the outer limit of the atmosphere. The density of dry air at sea level is about 1/800 the density of water. At higher altitudes it decreases rapidly, being proportional to the pressure and inversely proportional to the temperature. Pressure is measured by a barometer and is expressed in millibars, which are related to the height of a column of mercury that the air pressure will support. 1 millibar equals 0.75 millimeters, 0.03 in, of mercury. Normal atmospheric pressure at sea level is 1013 millibars, that is, 760 millimeters, 29.92 in, of mercury. At an altitude of 5.6 kilometers, about 3.5 miles, pressure falls to about 507 millibars, about 380 millimeters/14.96 in of mercury. Half of all the air in the atmosphere lies below this level. The pressure is approximately halved for each additional increase of 5.6 kilometers in altitude. At 80 kilometers, 50 miles, the pressure is 0.009 millibars, 0.0069 millimeters/0.00027 in of mercury. The troposphere and most of the stratosphere can be explored directly by means of sounding balloons equipped with instruments to measure the pressure and temperature of the air and with a radio transmitter to send the data to a receiving station at the ground. Rockets carrying radios that transmit meteorological instrument readings have explored the atmosphere to altitudes above 400 kilometers, 250 miles. Study of the form and spectrum of the polar lights, see aurora, gives information to a height possibly as great as 800 kilometers, 500 miles. AI, robot. Atmospheric pollution is the contamination of the air in the Earth's atmosphere by noxious gases, chemicals, particulate matter, and biological molecules. It occurs when pollutants are released into the atmosphere in quantities that exceed natural background levels. Atmospheric pollution can cause a variety of health problems, including respiratory infections, heart disease, and cancer. It can also damage crops and ecosystems. There are many sources of atmospheric pollution, including transportation. Cars, trucks, and airplanes emit a variety of pollutants, including carbon monoxide, nitrogen oxides, and particulate matter. Power plants, Power plants burn fossil fuels to generate electricity, which releases pollutants into the air. Industry, factories and other industrial facilities emit a variety of pollutants, including sulfur dioxide, nitrogen oxides, and particulate matter. Agriculture is a major source of air pollution, primarily from the use of fertilizers and pesticides. Waste management, landfills and incinerators release methane, a greenhouse gas, and other pollutants into the air. There are a number of things that can be done to reduce atmospheric pollution, including improving energy efficiency. Using less energy means burning fewer fossil fuels, which will reduce emissions of air pollutants. Switching to renewable energy sources, such as solar and wind power, do not produce air pollution. Reducing emissions from vehicles, cars, trucks, and airplanes can be made more fuel efficient, and cleaner fuels can be used. Controlling emissions from power plants can be fitted with pollution control devices, such as scrubbers and filters. Reducing emissions from industry, factories and other industrial facilities can be made more energy efficient, and cleaner production methods can be used. Reducing emissions from agriculture, farmers can use less fertilizer and pesticides, and they can adopt practices that reduce soil erosion. Improving waste management, landfills and incinerators can be designed to capture and control emissions of air pollutants. Reducing atmospheric pollution is essential to protect human health and the environment. By taking steps to reduce emissions from all sources, we can make a difference in the quality of the air we breathe. The atmosphere is a complex and dynamic system. It is constantly changing in response to the sun, the Earth's surface, and human activities. The atmosphere is a vital part of our planet. It is important to understand the atmosphere and how it works in order to protect it. Thank you for watching till the end of the video, and for more similar this video please subscribe this channel.